Okay, linear system solved. And what we're going to do is solve this particular linear system. So stick with me. I'm going to teach you what a linear system is in contrast to just a system. And we're going to talk about some various techniques that you need to know as an algebra student or math student at typically in middle school, high school level, and even in college level to be able to understand how to solve a system like this one here. Before we get going, I do a ton of math videos, so if you are looking for additional help on math, hope you consider subscribing to my channel. In addition, I have full and complete comprehensive math courses that you can use to kind of supplement your education, review, or actually take one of my courses. I'll leave a link in the description of this video to my academy. All right, with that being said, let's get into it. Linear system. Now, when we're talking about systems, all right, and by the way, we're going to solve this problem. That's the main focus. But I want to review big picture concepts about systems. Now, this is not going to be a complete full lesson because that would just take too long, but I do want to highlight some things. So that's kind of where I'm going here. So I'm going to give you some abbreviated review of systems, but there's, I'm leaving out things because it's in the interest of time. Okay. So systems in general in mathematics are extremely important. Okay. And typically what they are, they're they're things, they're equations, okay? Let me just start off this way. They're equations, but they're more than one equation, okay? And they're going to have more than one variable. So here we have two equations. If we notice, we have two equations here, and we have two variables. So generally speaking, the number of variables we have, here I have an x and y, I have two variables. If you have two variables, you'll need two equations to solve this system. Okay, so if I had a three variable system, x, y, z, I would need three equations in my system. Now, you identify systems with these little brackets. Okay, that's the most common notation, these little brackets around the equations. And basically what a system it's a mathematical model that represents one kind of concept, all right? So that's one way to think of a system. More specifically, and when we're talking about linear systems, there's another good way to think about this. And so this is, I'm going to start branching off on what a linear system is, okay? Now, some of you might be like, oh, I'm bored with this. I just want to see the solution to this problem. Well, if you should actually pause the video and see if you can actually solve this problem. Because if you can't solve this problem right off the bat, then you need to listen to all this kind of other stuff that I'm saying, because that means you need to strengthen your knowledge about systems. The more you understand about what a system is, the better you're going to be at actually solving them. Don't focus in math. Just don't focus on, okay, just tell me the steps to solve this problem, because that's where you get lost, okay, as a math student. You're like, oh, I just need to solve this problem. But if you don't even know what the problem represents or what the terms mean about the description of this concept, then you're doing yourself a big disservice, and it's going to show up later in your work. So let's get back to this. So we're talking about a linear system. So I gave you a rough idea what a system is. A linear system now, this word linear is, think of the word line, okay? That's the root word here. So we're talking about line systems, if you will. So in that case, what we're really looking at here, these two equations represent two lines. So go back to graphing lines, like with y equals mx plus b. So for example, if I told you to graph the line y equals 2x plus 1, could you graph that line? If you're studying systems, you should already know how to graph a line in algebra, okay, on an xy plane. So I'm just kind of assuming that you know how to do that, right? So this is the kind of line equation I'm talking about. We would refer to these guys as linear equations. So we're talking about a linear system. So this is like one line, line 1, and this is like another line, line 2, okay? So these are the equations of two separate lines. So in linear systems, when we solve, when we're trying to solve for the solution, what we're really doing is trying to determine or trying to find where the two lines intersect. So here I have line 1 and I have line 2. If these two lines cross, okay, they cross at a particular point, let's say 3, 8, okay, this is the solution. Remember, in algebra on the xy plane, the first number is x and the second number is the y coordinate, right? So here, x and y, these x's and y's are the same x's and y's that we think of on an xy plane. So the solution to this system, graphically speaking, is the location where the two lines intersect, okay? That's very, very important to understand. So if you're like, oh, okay, I got that. So let's just talk very briefly about the way we can approach to solve this system then, okay? There's three main techniques that you solve. There's other techniques. I'll touch on them very quickly here in a second. But let's just talk about the main core techniques to solve a system. The first is the graphing method. Okay, graphing. And basically, that's exactly what I just did here. You can graph these lines and look. Just like look on your paper, look on your graph paper, and say, oh, look, the lines cross at that point. And that if you can identify the intersection of the lines by physically graphing the lines, then hey, you got the solution. Okay, because remember, we're just trying to find out where the two lines intersect. So there's the graphing method. But this method here is not practical because what if these two lines crossed at the point 1, 1, 1, 4, and negative 57, okay? Like these coordinates. Like they're way off your graph paper, right? You'd have to have a graph paper the size of a basketball court to like plot this out. So graphing is not a good method. You need to understand it for sure to understand the concept of this, but it's not a practical method. So we don't really rely on this too much. What we do rely on big time is the substitution method and the elimination or linear combination method, okay? So these are algebraic methods to solve a linear system. Now, as you progress in mathematics, I'm not sure where you're at in math, but let's suppose you're at the Algebra 2 level, college algebra level. You're going to start learning about matrices, okay? And within matrices, that whole topic, there's additional ways to solve systems. And there's even more advanced ways. So systems are very, very important in mathematics and in business, science, engineering. You're like, as a math teacher, one of the common things that you hear all the time is, yeah, when am I going to use this? I'll never use that. Trust me, all this stuff has direct application. Your cell phone network, your internet, all that good stuff that we enjoy, servers, routers, just endless amounts of things involved application of this mathematics. So, I wouldn't be, saying like, oh, when am I going to use that? Trust me, people use this. There's direct applications for real life stuff to know that. And so it's crazy though, because some of the systems, they don't have two variables. They may have like hundreds of variables in their systems. So it requires actually computers to help us solve these systems. But the computer is just a tool. The computer is effectively running the same steps that we're going to kind of do here. It's just speeding up the time to do it, because we don't want to solve a 100 by 100 variable system that might take us like 6 months to solve or some ridiculous time. So that's why we use computers. But the steps, remember the computer is just a tool. But anyways, I don't want to get too far off topic here. This is the big picture, okay? So you as a math student at this time, you need to understand the graphing method, but you have to really, really master the substitution and the elimination and combination methods, okay? All right. Again, I know for me, I always want to leave my students with more information, not less, and I don't want to over teach you because that's for like a formal instruction. Okay, there's a time and place for that. But believe me, everything I'm telling you is critically important, and it's from experience. Okay, if you understand what I'm telling you here, then you're going to do really well. At a fundamental level. Okay, now let's get back to solving this system. Okay, so I don't know if you actually had a chance to actually pause the video and try to solve this, but if you haven't, maybe you want to give it a try. All right, so I'm going to tell you the answer, and then we'll actually solve it. So the solution to this system is 2, 1, okay? Remember, this is an ordered pair. It's a coordinate. It's a point on the xy plane. So the 2 is the x, and then the 1 is the y, right? This is the xy point. So in other words, x is equal to 2 and y is equal to 1. So we know, we can check that this is the solution by plugging in these values. So I can plug in the 2 right here for x, and then I would plug in 1 for y, and let's just check this guy real quick, if in fact these are the solutions. So 5 times x, but remember x is equal to 2, so that's 5 times 2, plus y is equal to 1, so that's 1. Is that in fact equal to 11? Well, that's 10 plus 1. Is that 11? Yes, 11 is equal to 11. That's true, okay? So this is how we check a solution, but you just can't check one equation. We have to check both equations. So let's check the second one, make sure this works here. So that's going to be 3 times what? 2, because that's what x is equal to, minus 2 times 1, because that's what y is equal to, and is that equal to 4? So 3 times 2 is 6, 6 minus 2, is the left equal to the right? 6 minus 2 is 4, 4 is equal to 4, boom, okay? So this solution, okay, works, satisfies both equations. Okay, when we plug in the values for x and y, the left-hand side equals the right-hand side. So now we know we got a good solution here. Okay, so one of the things you can do if you're not confident in your solution, you're like, oh, do I have the right answer or not? You can always check your work if you have time. Okay, so you want to get in the habit of knowing that, but that's something you need to understand already, because I can pose a question in a math exam saying, is this the solution to this system? Now you have two choices. You can try to solve the system and see if the answer matches, but that's like a long way of approaching it, or you can just plug in the values and see if the left-hand side equals the right. Either way, you need to understand the concept, okay? All right, so let's see here. Well, we have the substitution method and the combination method. I think I'm going to use the elimination combination method. I have videos on the substitution method, so subscribe, check those out, and if you need more practice, you want to see a lot of problems solved in detail, step by step, then you want to go to my academy. You want to check out my algebra courses, Algebra 1, Algebra 2, and beyond all those courses. I will teach systems. But let's use the elimination method here. So the elimination method, and by the way, they're both, you need to know both of these methods, and they're both great methods. They're just two tools, and sometimes you'll see an opportunity to use one versus the other, but here's the deal with the elimination combination method. So let's just write this out. The elimination and combination method, or linear combination. So elimination is this. What we want to do is eliminate one of the variables here. Okay, so I have x and y's. I'm going to do something to eliminate all the x's or all the y's just temporarily. Okay, now the way I'm going to eliminate these guys is through combining them. I'm going to smash them down like a sandwich. Okay, linear combination. I'm going to combine these two. I'm going to add them up to form a new equation, and then go from there. So I'm going to show you how to do this. Just try to follow the patterns. Again, you know, I have complete full lessons on this on other videos, etc. But let's get right to it. So I'm looking here. I'm thinking, you know what? I want to eliminate the y variable. Let's eliminate the y variable. Okay. So what you can do in systems, you can always add. You can do, one of the rules that are allowed. You can add down, okay, and form a new equation that can be can replace any other equations inside the system. That might be confusing to you, so let me just show you, okay? So let's add down in a column manner. Boom, boom, boom. Okay. So I have 5x and 3x, that's 8x, okay? I add down this way, I get what? Negative y. And I add down here, I get a 15. So I have 8x minus y is equal to 15. So this equation here, I can actually just replace this the second equation or this first equation with this equation. And guess what? If I solve that new system using this equation, by substituting out any one of these guys, I'll still get the same answer. So combining two equations of the system that forms a new equation doesn't, you can use that to still solve the system, okay? So I'm speaking in generalities here, but I need you to understand that this is allowed. Now, another thing that's allowed that we can manipulate systems in all kinds of cool ways, is we can multiply. So I can multiply this entire system by 2, and it doesn't break the system, if you will. So let's do that. So 2, we're just going to distribute to all these guys. I'm going to get 10x plus 2y is equal to 22. Awesome. Okay, so this equation here is equivalent to this first equation. I just made it bigger by multiplying everything by 2. As long as I did it, multiply this number by everything, then I'm okay. So what I'm going to do is I'm going to keep these rules, these are called row combination rules and things, these are all allowed when you're manipulating systems. So what you want to do is kind of change the system around such that we can eliminate a variable. So I'm going to show you that right now. So I'm going to multiply the first equation by 2, just like I did here. And I'm going to keep my original bottom equation. So that's 3x minus 2y is equal to 4. And let me kind of move these brackets, make them a little bit smaller. Now, hopefully you notice something here. I'm going to go ahead and combine now. I'm going to use that first technique, or that first rule that I told you we can do by sandwiching these guys together. When I sandwich these guys together here, what's going to occur? Okay, well, I get 10x plus 3x is 13x. And out of the y's, I get 2y minus 2y, or a positive 2y plus a negative 2y is 0. I just eliminated the y variable, okay? Equals 22 plus 4, and that's 26. Okay, now we're getting someplace, right? So that I'm left with this equation, 13x is equal to 26. So now I have one equation with one variable, and I can solve this. All right, this is a real basic one-step equation, so I just divide both sides by 13, and x is equal to 2. That's exactly what we had up here, right? So now we're halfway home. We have one of our coordinates answered, okay? We know what the x or the y is. Sometimes you can get the y first, and you need to get the x. In this case, we got the x first. So now we're like, perfect. How do we get the y? Okay? So before I move on and show you how to finish this up, here's the key. When you're using the elimination method, you need to manipulate one or both of the equations in the system such that you get a scenario that when you add down, a variable goes away, just like I showed you right here. Okay, it's not difficult, but yeah, you have to be a little creative to do it, and there's not any one single way to do it. Okay, there's all kinds of paths you can do. For example, if I wanted to use fractions, I could have kept this guy, my original one, and multiplied this second one by 1/2. And by doing so, I would get a negative y, right? Because 1/2 times this 2y is just negative y, and then I can add down and get the same results. I can still have eliminated a y that way. But I chose not to do that because I would get a fraction here. I would get a 3/2. And I'm like, yeah, I don't want to deal with fractions. Okay, so again, this stuff takes time, it takes experience, and you got to practice it. Okay, but it's not hard. It's just like anything. It just you got to build up your skill set. Okay, so let's finish this problem up. So hopefully you're understanding this. Let me erase all of this right now. So now we have x is equal to 2. Now typically if I was actually doing this with paper and pencil, I would be writing everything out step by step, but I'm trying to keep everything on one kind of page here so we don't move things around. So we know x is equal to 2. Okay, we just solved that. Now we need to solve for y. So what's y equal to? Well, this is really easy because we can use one of these equations. Doesn't make a difference which one. I'm going to use the first one, okay? 5x plus y is equal to 11. So we just pick an equation, and we're going to substitute in the value of the variable we just solved for, okay? So x is equal to 2. We're going to replace that right here, okay? We're going to replace this x for the actual value 2 because that's what it's equal to. That's 5 times 2 plus y is equal to 11. So here I'm going to be able to solve for y. So this is 10 plus y equals 11. Subtract 10 from both sides, and I get y is equal to 1. And that's exactly what I told you what the solution was. And remember, we verified that, in fact, 2, 1, x is equal to 2, y is equal to 1, is indeed the solution. Okay? So that's going to wrap it up for this problem. There's a lot. I could have approached this problem using a substitution method, okay? But I wanted to give you the big picture of what a system is, what the solution represents, etc. Before I leave you real quick, I want to throw in one other little bonus concept. So 2 lines, right? That's what we're trying to do. We're trying to look for the intersection point of where 2 lines cross. That is the solution to a system. But sometimes you have 2 lines that are actually parallel to one another, okay? So graphically speaking, if you have 2 lines that are parallel to one another, then there is no solution, okay? So that can happen. Sometimes you can have no solution, but graphically speaking, there are 2 lines that just never cross. They're parallel. And then you can also have a line, and then the next line actually rests on top of the second line. So here you have infinitely many places of intersection. So the 3 possibilities you have when you're dealing with the systems is to have one solution, no solutions, or infinitely many. And that's for another video, okay, when you recognize what's going on here. Okay, systems, you got to know them. Extremely important topic. Let's wrap this up. So again, I do a ton of videos on this stuff, so I hope you consider becoming a subscriber. And if you do, make sure you hit that bell notification. And if you enjoyed this video, I would definitely appreciate a thumbs up and leave me some feedback. It's a way to let me know what you're thinking, how I'm doing, and get some ideas on future videos that will benefit you. One last reminder, if you're looking for complete full instruction, if you like my teaching style, then you really want to check out my complete courses, because I really teach in detail and I go over lots and lots of problems. I do a lot of that stuff on my YouTube channel, but I do it in a more formal manner in my academy. So again, I'll leave a link in that to that in the description of this video. But with that being said, I appreciate your time and have a great day.